Hello everyone, welcome to our channel. Today we're diving into the orderBy function in PySpark. Sorting data is one of the most important aspects of data analysis. It helps you find trends, understand your dataset better, and present the results clearly. In this video, I'll guide you through how to use the orderBy function effectively to sort your data frames in both ascending and descending order. Whether you're just getting started or looking to refine your PySpark skills, this is the video for you. Introduction to the orderBy function. The orderBy function in PySpark is a versatile tool that allows you to sort the rows of a data frame based on one or more columns. This function operates similarly to the orderBy clause in SQL, making it straightforward for users familiar with UL to transition to PySpark. By using orderBy, you can specify whether you want the data arranged in ascending or descending order. This is particularly useful for organizing data to improve readability, highlighting top or bottom performers, or preparing data for further analysis. For example, you might use orderBy to sort sales records from highest to lowest, making it easier to identify key trends in the data. It's one of the most frequently used functions in data processing as it ensures that the dataset is logically arranged for easier interpretation and subsequent operations. Basic syntax. The basic syntax for the orderBy function in PySpark is straightforward and flexible, allowing you to specify multiple columns for sorting. You can use orderBy followed by the columns you wish to sort, and you have an option to decide whether the sorting should be in ascending or descending order. By default, the ascending parameter is set to true, meaning that the data will be sorted in ascending order unless otherwise specified. If you need to sort by multiple columns, you can pass these columns as a list. And similarly, you can provide a list of Boolean values to determine the sorting order for each respective column. This level of control is especially useful when working with datasets where sorting needs to be done on multiple criteria, such as sorting by date and then by category. The orderBy function helps bring order to your data, making it easier to understand and interpret. Why use orderBy function? The orderBy function in PySpark is highly useful for organizing and presenting your data in a meaningful order. By sorting data in either ascending or descending order, it becomes significantly easier to analyze trends, identify extremes such as maximum or minimum values, and understand patterns within your dataset. Whether you're working with numerical data, timestamps, or strings, orderBy can help make your data more readable and interpretable. This function is often utilized in reporting to create a clear, understandable structure for viewers. Moreover, it's beneficial for ranking, whether you're showing top performers, highest sales, or most recent entries. It's also commonly used as a pre-processing step before additional data analysis or visualization to make sure the dataset is in the appropriate sequence, enhancing both clarity and impact. Practical examples. 1. Sorting data in ascending order. In this example, we are working with a PySpark data frame that contains sales information for different items. The data frame consists of two columns, item and sales. The item column represents the name of each item, while the sales column contains the corresponding sales value for each item. After defining the data frame, we use the orderBy function to sort the rows based on the sales column in ascending order. Sorting the data in ascending order means that the values are arranged from the smallest to the largest. Specifically for the sales column, this means that the items with the lowest sales value appear at the top, while those with higher sales values are displayed towards the bottom. This type of sorting is especially helpful for gaining insights from the data. For example, if you are interested in determining which items have the lowest sales figures, sorting in ascending order provides you with an immediate view of which items might need more attention or improvement. It also helps in performing analysis that focuses on identifying potential growth areas, making business decisions, or identifying opportunities to enhance sales performance. Additionally, sorting can improve readability and organization of the data, making it easier for analysts or stakeholders to understand and interpret the sales distribution. In data analysis and reporting, presenting sorted data can provide clarity, which ultimately aids in making well informed decisions. Finally, we use the show function to display the sorted data frame, which allows us to view the output directly and see the results of our sorting operation. This way, we can visually confirm that the items are ordered from the lowest to the highest sales, giving us an easily interpretable view of the data. To sorting data in descending order. In this example, we have a data frame containing item and sales columns, and we want to sort the rows based on the sales values in descending order. We achieve this using the order by function on the sales column with the parameter ascending set to false. This ensures that the values are sorted from the highest to the lowest. Sorting in descending order is particularly useful when you want to focus on the top performing items, such as identifying the products with the highest sales. It can be helpful in analyzing which items are contributing the most to overall revenue or prioritizing the items that are performing well. For instance, in a business context, you might want to target these top items for promotional campaigns or further investment because they are already demonstrating strong sales performance. Using order by in descending order also helps make important data more visible at a glance, as the most significant or largest values appear at the top of the list. This can improve decision making, making it easy to quickly identify trends, patterns, or outliers that warrant attention. Finally, we use the show function to display the results, allowing us to see the data frame where the items are sorted by sales from the highest to the lowest value. This type of output makes it much easier to interpret and draw conclusions regarding the top performing items in the dataset. 3. Sorting by multiple columns. In this example, we are sorting the data frame first by the item column and then by the sales column, both in ascending order, using the order by function. By specifying the column names in this way, we can ensure that the rows are sorted hierarchically first based on the values in the item column and then by the values in the sales column within each item group. This kind of sorting is particularly useful when you need to organize your data by multiple columns, providing a structured and easy to follow view. For example, grouping the same items together helps you quickly analyze the performance of individual products, while sorting by sales within each item group makes it easier to see the variation in sales figures. By ordering in this way, you can gain a clear overview of your dataset, making it more readable and organized. It is especially useful for business analysis where you need to understand trends in product performance or compare similar items. This hierarchical sorting approach can be used to identify specific patterns, such as which items have consistent or fluctuating sales over time. Finally, the show function is used to display the sorted data frame, making it easy to visually interpret the results where all items of the same type are grouped together and each group is further sorted by their sales value in ascending order. This allows for better readability and facilitates deeper data insights. 4. Sorting by multiple columns with mixed orders. In this example, we are sorting the data frame using the order by function, but with two columns, item and sales. We are sorting the item column in ascending order while sorting the sales column in descending order. To achieve this, we use a list to specify the sorting order for each column, true for ascending and false for descending. The resulting data frame will first be grouped by the values in the item column in alphabetical order, ensuring all entries for a specific item are adjacent to each other. Then, within each group of items, the rows are sorted by the sales value in descending order. This approach allows us to see each item listed together, while the individual sales values for each item are arranged from the highest to the lowest. This type of sorting is particularly helpful when you need to see items grouped together but also want to quickly identify the highest or lowest values within each group. For example, in a business scenario, it allows you to compare top sales figures for each product without losing the natural grouping of products, providing a clear and comprehensive view of which items are performing better compared to others. Finally, the show function displays the output data frame, giving an organized view where you can easily see the top sales within each item group while keeping the items listed in ascending alphabetical order. This approach is excellent for data analysis, reporting, and gaining insights into product level performance. 5. Sorting by column expressions. In this example, we are sorting the data frame using the orderBy function based on a computed value rather than an existing column. Specifically, we use the XPI function from PySpark to create an expression that increases the sales column values by 10%. The XPI function allows us to write SQL-like expressions, and here it multiplies the sales value by 1.1 to represent a 10% increase. Once the XPI sales 1.1 expression is created, the orderBy function is used to sort the data frame by this newly calculated value. This means that the data frame rows are ordered based on the hypothetical increased sales values rather than the original values in the sales column. This approach is useful for scenarios where you want to perform calculations and sort the data based on those computed results rather than sorting by static column values. For instance, if you need to determine the priority of products after applying a potential price increase or discount, this method can quickly help you visualize which products will generate the highest or lowest revenue after such an adjustment. Finally, the show function displays the result of the sorted data frame, giving you an organized view of how the sales numbers would look if they were increased by 10%. This makes it easy to analyze and understand the impact of changes to pricing or sales performance. 6. Sorting null values. In this example, we have a data frame called df underscore with underscore nulls that contain sales data for different items, and some of the rows have none values representing nulls in the sales column. Null values can sometimes complicate sorting, and depending on the context, we may want to place them either at the beginning or at the end of the sorted results. To handle these situations, we use the orderBy function in PySpark, which gives us control over how null values are treated when sorting. First, we use df underscore with underscore nulls dot sales dot se underscore nulls underscore first to sort the data frame in ascending order based on the sales column, while ensuring that the rows with null values appear at the top. This is helpful when you want to prioritize seeing incomplete or missing data first, making it easier to identify and work with those entries. Next, we use df underscore with underscore nulls dot sales dot ase underscore nulls underscore last to sort the data frame in ascending order, but this time any rows with null values are placed at the end. This approach is useful when you want to focus on valid sales data without immediately seeing nulls, or when you want to analyze the non-null values before reviewing the missing ones. These sorting options allow for greater flexibility in dealing with null values, making it easier to structure your data for different analysis needs. The final show command displays the sorted data frames, showing how the placement of null values differs depending on the chosen sorting method. That's all for today, everyone. I hope you now have a solid understanding of how to use the orderBy function to sort your data easily and effectively in PySpark. If you found this video helpful, don't forget to like, share, and subscribe to stay updated on more PySpark tips and tutorials. If you have any questions or topics you would like me to cover next, leave a comment below. Thanks for watching and see you in the next video.